Look, it is not completed yet because the final solution it is in terms of t bar. Actually ये जो y है वो t bar का फंक्शन है, ठीक है। तो अल्टीमेटली सोल्यूशन क्या होगा, मतलब सोल्यूशन शुड बी इन टर्म्स ऑफ y एंड t। तो at last you have to use the substitution, okay, this substitution, uh, t bar, that is t minus 2, fine। so lastly I will write the solution. In the solution I will put t minus 2। तो in that case the solution will be a में जो भी जहां पे भी t रहेगा वो t के जगह जहां पे t बार रहेगा you put that t bar is equal to t minus 2। तो I'm just instructing you, I'm not ready because I don't know what is a substitute t bar is equal to t minus 2। we get जो भी मिलेगा that will be the solution, okay। if you missed this part, so to substitute t bar, then definitely some marks will be deducted because the final answer that should be in terms of y and t bar we additionally taken, we have substituted it, right। तो समझ गया ना क्या क्या करना पड़ेगा। आई मींस आई हैव इग्नोर्ड सम पार्ट, यू हैव टू कंप्लीट इट।
यस सर, बस ए निकलना है ना।
हाँ, यू हैव टू फाइंड ए एंड लास्टली
और टी को
y t is y t bar is equal to this and finally the solution, मतलब यहाँ पे t bar को t minus 2 substitute।
यस सर गॉट इट।
so you can solve one or two more problems from the exercise by your own। uh, there are several problems in the exercise 12, 13, 14, 15। so I have solved problem number 14, so you can solve the rest 12, 13, 15। so it is now completed, right? Chapter 6.2 completed because we have solved all types of problem 1 to 11 I have solved some problems, 12 to 15 I have also solved one problem, 16 to 21 I have shown how to solve this type of problem, and 23 to 29 finding Laplace inverse by the formula that f is by s, Laplace inverse of f is by s। if you have any kind of doubt in this chapter or exercise problems you can ask। अगर अगर ट्राई किए हो, सॉल्व किए हो खुद से तभी जाके डाउट रहेगा, नहीं तो नहीं रहेगा। Okay, now I am coming to 6.3। so here I'm going to introduce a popular function. It is actually popular, or it is heavily used in engineering problem. This function, unit step function, or it is called Heaviside function. You have heard this, heard about this function before, right? Many of you know this unit step function. Don't know? किसी किसी को भी पता नहीं है यूनिट स्टेप फंक्शन और हेविसाइड फंक्शन?
No, sir.
No, means have you seen a graph with step size 1 like this? Minus infinity to 0 it is 0 and 1 to infinity it is 1. So it is a graph with step size 1. That height is 1. Okay, the unit of the height, that is 1. So it is called unit step function. A graph whose step length means height, it is 1. So it is called unit step function or Heaviside function. I am showing you the formal definition of it. Unit step function or it is called Heaviside function. So it is defined as, the notation is u t minus a. Okay, u t minus a. It has two pieces. Uh, one piece it is the value 0 to the left of this value a, and 1 to the right of this a. Ut minus a, that is the notation of unit step function. Ut minus a, small ut minus a, its value is 0 whenever t less than a, and 1 whenever t greater than a. And we are taking that the function is not defined at t is equal to a. Okay, मतलब a पे वैल्यू क्या होगा वो not defined. In some book actually the function is defined at a, means you can put the inequality in any case, either in first or in second, that is also okay. But according to your book, basic book, uh, at the point t is equal to a, the function is taken as undefined. Okay, ut minus a value 0, t less than a, and value 1, t greater than a. And यहाँ पे here that a should be greater than or equals to 0. Fine. So what will be the graph? What will be the graph of it? The graph is, already I have shown just a few minutes back. Say at the point A lies here, the positive uh, t axis. Okay. Then whenever t less than a, the value is 0. That means it is lying on this axis, a t axis, right? And whenever t greater than a, the height of the function, it is 1, and it continues till infinity, t greater than a. Fine. So that is the graph. ये यूनिट स्टेप फंक्शन देखो एकदम नाम के साथ ही ये ग्राफ का मीनिंगफुल है, बिकॉज द means length of the step, height of the step, that is 1, right? ये हाइट कितना है, दोनों दोनों ब्रांच जो है 0 एंड 1 में हाइट कितना, हाइट का डिफरेंस कितना है, 1.
Sir,
हाँ,
सर टी यहाँ पे लिखा है कि डी अगर ग्रेटर होगा ए से तो 1 होगा।
हम्म।
मतलब टी माइनस ए अगर 0 से ग्रेटर होगा तो 1 होना चाहिए, तो स्टार्टिंग से होना चाहिए ना।
टी माइनस, देखो टी ग्रेटर देन ये तो एक पॉइंट है, आई टोल्ड दैट मीन्स टी ग्रेटर देन मतलब ए का राइट,
यस सर।
एंड टी लेस देन मतलब ए का लेफ्ट, तो वही तो किया है ना।
यस सर।
Okay, now a specialized case is that if whenever a is equal to 0, तो a is equal to 0 लेंगे तो it is ut, तो what will be the definition? Ut, it is 0 whenever t less than 0, 1 whenever t greater than 0, right? That is a particular case of this. If we take a small a is equal to 0, so in that case you can also plot the graph. In that case the graph means non-zero part start from the y-axis, मतलब ये origin ये हो गया a का वैल्यू 0, this that height is 1. Okay, any doubt?
नो सर।
Is it continuous function, heaviside function?
सर।
Is it a continuous function?
यस सर।
मतलब ऐसे ग्राफ अगर होगा तो ये कंटिन्यूअस,
ओके ओके, दैट्स नॉट अ लाइन। यस सर, नॉट कंटिन्यूस।
there are a jump discontinued है ना, because that at
यस
a
सर।
certain point the graph jump from 0 to a, 0 to 1, not a, 0 to 1. Okay, so that unit step function or heaviside function, it is not continuous at t is equal to a. Other at other points the function is continuous, but t is equal to a point में continuous नहीं. Okay, now here we are interested on finding the Laplace transform of this heaviside function. Okay, so what is the formula for Laplace transform of ut minus a, that we should know. So Laplace transform of u t minus a, it is equals to e to the power minus as divided by s. We can means we can prove it in a simplest way by using the definition. Okay, but that proof is not important. How we are getting that Laplace transform of ut minus is equal to this. You have to remember this as a formula. It is like a tabulated formula. Okay, Laplace transform of ut minus a, it is equals to e to the power minus as divided by s. Fine.
Yes,
And
sir.
definitely s जो है वो greater than 0 होगा, नहीं तो ये define नहीं होगा, ठीक है. During the proof you will realize it that s should be greater than 0. So here s, the condition on s is that s should be greater than 0. So that is the formula. uh, Similarly means from that we can derive the Laplace inverse formula. So Laplace inverse of, what will be the formula? Laplace inverse formula, e to the power minus as divided by s, it is equals to u t minus. Okay, Now from now on, means fs contains some e to the power minus something into s term. Because previously we have also we have also calculated some Laplace inverse. There we have used the formula, means s shifting or fs by s case or derivative case. Okay, but nowhere e to the power minus as type of function included. Have you found any means fs there which includes e to the power minus as type of term previously, up means in 6.1 or 6.2? वहां पे fs e to the power minus as type of term को contain नहीं करता था, right? Are you getting what I meant to say, or not getting anything? Are you getting? Look, you go and search, means from in 6.1. Have there any function of fs, which includes e to the power minus something into s? कहीं पे भी है ऐसे देखो तो, in this formula also. Anywhere means e to the power minus as type of term is there. fs, okay. fs वो e to the power minus as वाला टर्म देखो कहीं पे नहीं है, यहाँ पे नहीं है टेबुलेटेड फॉर्मूला में, right?
सर सिक्स्थ में है।
Sixth, it is e to the power at. It is t function. I am telling about s function,
ओके
fs.
यस सर।
मतलब लैपलास ट्रांसफॉर्म लेने के बाद जो आ रहा है उसमें e to the power माइनस समथिंग इनटू s टाइप का फॉर्म है,
नो
कहीं
सर।
पे इससे रिलेटेड नहीं है. You can search. And means anyhow by shifting by shifting theorem, or by using the formula in the next chapter, like this derivatives formula, or uh, this fs by s form, anywhere you can see fs which contain e to the power minus s related, nowhere. So from now on, क्योंकि now we can see that for Laplace transform of heavy side, it contains e to the power minus as term. Okay, Laplace transform of ut minus a, it is e to the power minus as divided by s. So it contains e to the power minus as related term. So from now on, if a function of s contains e to the power minus as, in that case you think that it is related to heaviside function. Okay, मतलब अभी से ये सब क्वेश्चन दे सकता है कि व्हाट इज द लैप्लास इनवर्स ऑफ e to the power minus 2s divided by a square plus 1. So to solve it you need more knowledge actually, but from now on this type of question may ask e to the power minus 2s divided by a square plus 1, what is it? Fine.
यस सर।
एक्चुअली क्या हो रहा है कि इन द डायरेक्टरी ऑफ दिस Laplace and Laplace inverse, we are adding new type of functions. Chapter to chapter we are adding new type of functions. Okay, now here in that part you can read it. It is written that how that heaviside function can be used in engineering problem. Okay, मतलब क्यों ये हेविसाइड फंक्शन लेके यहाँ पे हम लोग लैपलास ट्रांसफॉर्म ले रहे हैं. So because it is related to heaviside function, means sorry, because it is related to engineering problems, you can read, I'm reading, you can see. The unit step function is a typical engineering function made to measure for engineering applications, which often involve functions that are either off or on. So in electrical, you have seen, you know that means there have a switch which is either on or off. So there are many type of function which include this type of means many engineering problems which include this type of on off function. Okay, now ये हेवी साइड फंक्शन जो है ये कैसे वर्क करता है, मान लो कि दैट ऑन ऑफ फंक्शन इज एफ टी. ओके, नाउ मल्टीप्लाइंग द फंक्शन एफ टी with ut minus a, that can produce various type of effects. Okay, ft into ut minus a, this multiplication can produce all sort of effects. तो यहाँ पे दो टाइप का इफेक्ट के बारे में दिया गया है. You see the figure, this 120 ft, graph of ft is drawn. Okay, then next ft ut minus 2, ft ut minus 2, that is the graph. So ft u minus ut minus 2, actually it is starting from 2, previous portion जो है that is removed, and ft minus 2 ut minus 2, it is another type. So ये क्या है, ये actually वो साइन साइन टी का जो ग्राफ है वो 2 यूनिट पूरा शिफ्ट हो गया. ओके, तो एफ टी इज इक्वल टू 5 साइन टी, it is a simplest simple function you can take. Okay, it is a simple function, and it is expanding from minus infinity to infinity, all of you know. Now if we multiply ft by ut minus 2, then what happens, actually वो 2 जो है ना वो अभी स्विच वैल्यू है. ठीक है, मतलब क्या होगा कि 2 से वो ग्राफ चालू होगा, t इज इक्वल टू 2 से वो ग्राफ चालू हो जाएगा. t से पहले जो था वो और नहीं रहेगा. द ग्राफ ऑफ 5 sin t that starts from 2. So 2 acts like a switch. फाइन. तो मतलब 2 सेकेंड, मान लो कि कोई एक इलेक्ट्रिक सर्किट है, वो मैं चाहता हूं कि 2 सेकेंड के बाद मतलब वो चालू हो. ठीक है, मैं टाइम पैरामीटर मतलब इंप्लीमेंट किया, तो 2 सेकेंड के बाद चालू हो, मैं अगर ये करना चाहता हूँ, इन दैट केस आई हैव टू मल्टीप्लाई एफ टी बाई यू टी माइनस 2. एंड एफ टी माइनस 2 यू टी माइनस 2 ये क्या है, ये है कि पूरा जो एफ टी है वो एफ टी मतलब 2 यूनिट राइट शिफ्ट हो गया, मतलब जो ग्राफ है वो ग्राफ तो पूरा माइनस इंफिनिटी टू इंफिनिटी ही रहेगा, बट दैट इज शिफ्टेड 2 यूनिट्स राइट. वो राइट यूनिट मतलब 2 यूनिट्स राइट शिफ्ट हो जाएगा. ठीक है, तो यू कैन रीड दिस एक्सप्लेनेशंस what is happening with multiplying that ft by ut minus 2. Fine. देखो, in figure 120 the given function is shown in a. So given function, it is shown in a. In b it is switched off between t0 to 2. ओके, मतलब ये 0 to 2 से स्विच्ड ऑफ हो कर दिया है, क्योंकि यू एफ टी को यू टी माइनस 2 से मल्टीप्लाई कर दिया. तो ये मीन करेगा कि means in b the function is switched off between 0 to 2. Okay, and switched on ये बिगिनिंग होगा एट t इज इक्वल टू 2, मतलब दो अब 2 से वो स्विच ऑन हो जाएगा. एंड सी पार्ट क्या बोल रहे हैं, इन सी इट इज शिफ्टेड टू द राइट बाय 2 यूनिट्स, मतलब पूरा ग्राफ शिफ्ट हो गया 2 यूनिट्स राइट में. इसमें ग्राफ का पोर्शन कुछ मतलब इग्नोर्ड नहीं है, पूरा ग्राफ ही है, बट ये बी पार्ट में ग्राफ का पोर्शन एक इग्नोर्ड है, 0 to 2। फाइन। सो ये दोनों टाइप का ट्रांसफॉर्मेशन वी कैन डू बाय अप्लाइंग हेविसाइड फंक्शन। डायरेक्टली मल्टीप्लाई एफ टी बाई यू टी माइनस टू, और एफ टी मतलब पहले एफ टी को शिफ्ट करो एफ टी माइनस टू पे, देन मल्टीप्लाई करो यू टी माइनस टू। ग्राफ का नेचर सेम रखता है, ये दोनों दोनों जो मैपिंग है ग्राफ का नेचर सेम रखता है, बट वो मतलब कोई स्विच ऑन स्विच ऑफ वाला काम करता है, या कोई राइट शिफ्ट हो जाता है। इन डाउट, टेल मी। हैव यू गॉट एनी नॉलेज, और कुछ भी समझ में नहीं है? टेल मी।
यस सर।
कोई कुछ रेस्पॉन्ड नहीं कर रहे हो, क्या बात है? एक बस एक ही रेस्पॉन्ड कर रहे हैं। आर यू लिसनिंग ऑल?
Yes, sir.
Yes, sir, listening, but my network is not good, sir. My Wi-Fi is not working today.
ओके, बट अदर्स?
यस सर।
Yes, sir.
Okay, so for better understanding, I suggest you read this paragraph. Okay, दोबारा पढ़ो ये क्या बोलना चाह रहे हैं,
Yes, sir.
and then you will realize about these three figures. And ये लाइन भी पढ़ सकते हो। यहाँ पे क्या बोला है कि actually if a function is defined in the negative real axis, look, usually we take Laplace transform of a function which is defined in positive real axis. Okay, now if a function is defined in negative real axis, then how we can take its Laplace transform? So in that case, you just take that shift ft minus a ut minus a, मतलब ये जो ft रहेगा, from that ft you construct ft minus a and then you multiply it by ut minus a. Okay, then ये क्या मीन करता है ft minus a ut minus a? इसका मतलब है कि you have shifted the graph, you have shifted the graph for ft a units. I have already told by this figure, right? ft minus a ut minus a मतलब वो a unit right shift हो गया. So by using that formula ft minus a ut minus a, from the negative axis you can shift the function to positive axis. तो ये सब देखो, हिस्ट्री अगर समझना चाहते हो तो समझ सकते हो थोड़ा कि क्या बोलना चाह रहे हैं। अदरवाइज मींस यू कैन फोकस ओनली ऑन द न्यूमेरिक प्रॉब्लम्स, बिकॉज इन द एग्जाम यू आर गोइंग टू गेट सम न्यूमेरिक प्रॉब्लम्स, दे विल नॉट ask you about this history. So you should know this function first of all. Okay, Laplace transform of ut minus a, then you can come to this second shifting theorem. That is important. To solve the problems we need this. देखो in 6.1, in 6.1 I think, in 6.1 I have introduced what fast shifting theorem, which is also called S shifting theorem, right? S shifting theorem बताया था ना, जो fast shifting theorem है, Laplace transform of e to the power at into ft, that is f of what, s minus a.
Yes, sir.
It is the fast shifting theorem formula. और एस शिफ्टिंग थ्योरम, एस को एस माइनस ए में लिख रहे हैं, दैट मीन्स वी आर शिफ्टिंग एस, So it is a shifting theorem. Now that theorem, it is T shifting theorem or second shifting theorem. Okay, second shifting theorem. So what second shifting theorem says, you see, uh, let Ft has the Laplace transform Fs, then what is the Laplace transform of Ft minus a ut minus a? So here the main formula is what will be the Laplace transform of Ft minus a ut minus a, provided you know Laplace transform of Ft. Okay, so the formula is e to the power minus as into fs. So why it is called t shifting? They go because we have taken the function ft minus a ut minus a from ft. So ये जो ft से ft minus a ut minus a लिख रहा हूँ, it is what? It is basically a unit right shifting ना. So we are shifting t to t minus a. We are shifting t. That is why it is called t shifting. So Laplace transform T shifting theorem says that Laplace transform of f of t minus a ut minus a, it is equals to e to the power minus as into fs, provided Laplace transform of ft is equal to fs. Okay, simply this you can remember. बाकी previously जो भी मैं explain कर रहा था, you can ignore this one. And consequently you can write the Laplace inverse formula, right? तो Laplace inverse formula हो जाएगा क्या? Laplace inverse of e to the power minus as into fs, that is equals to ft minus a ut minus a. देखो फॉर्मूला में तो कुछ डाउट नहीं होना चाहिए, ये तो मतलब बस याद रखना है. एंड कैसे ये फॉर्मूला आया वो भी डेफिनेशन से मतलब डिराइव कर सकते हो, बट नो वन विल आस्क यू हाउ वी आर गेटिंग दिस फॉर्मूला. फाइन. Laplace transform of ft minus a ut minus a, it is e to the power minus as into fs. That is the Laplace transform formula, and accordingly you can write the Laplace inverse formula, which is Laplace inverse of e to the power minus as into fs, which is equals to ft minus a ut minus a. Second set. Now one more thing that is also an important part of this chapter. Given a piecewise function, and if it is asked to find Laplace transform, how to find it? Look, previously we have seen Laplace transform of some piecewise function, which was given in terms of graphs in 5.1. 5.1 है ना? वो graphs का Laplace transform कहाँ पे दिया था? This 9 to 16. Find the Laplace transform of these graphs, and most of the graphs are piecewise functions, right? मतलब ये जो ग्राफ दिया था तुम ग्राफ के करस्पॉन्डिंग इफ यू राइट द function ft, that is piecewise function, means there are more than one piece, right? And here I have told that find the Laplace inverse by using what definition, integration use करके. Do you remember or forgot?
Yes, sir. Yes, sir.
Now I will show that means for piecewise function, means for this type of graph also we can use the formula. We can directly use the formula, no need to use the definition. तो piecewise function को कैसे मतलब इसके ऊपर कैसे लैपलेस ट्रांसफॉर्म लिया जाए, दैट इज अ क्वेश्चन. Suppose we have this function ft is equal to 2 0 to 1 interval, ft is equal to 1 by 2 t square 1 to pi by 2 interval and cos t greater than pi by 2. तो बेसिकली ये क्या है, मतलब कैसा टाइप ऑफ ग्राफ है. देखो अगर ड्रॉ करूंगा 0 to 1, ये मान लो कि 2 हाइट 2, देन t स्क्वायर, तो y is equal to x square, that is vertical graph. ऐसे कुछ बनेगा, ऐसे कुछ बनेगा, ठीक है. t टू पाई बाई 2, मान लो ये पाई बाई 2, 1 to पाई बाई 2, देन ग्रेटर देन पाई बाई 2 से इट इज व्हाट, cos t. सो cos पाई बाई 2 का वैल्यू क्या है, 0. तो ये एक्चुअली ऐसे ग्राफ बनेगा. It is the means graph of this function. Okay, 3 parts, 3 pieces. Fine. So for this graph Laplace transform क्या होगा, you can use the what, you can use the definition, you can use that integration formula, but without using how to find, without using that definition how to find. For that whenever a piecewise, you should know, whenever a piecewise function is given, you can represent it in terms of Heaviside function. Okay, so every piecewise function can be represented as a Heaviside function or in terms of Heaviside function. So how to represent it, that is the main part here. How to represent a piecewise function into in terms of Heaviside function, you see. तो ये जस्ट टेक्निक याद करो, याद रखना. ft, the value of the first piece, that is 2, then you see these 2 end points. So if it is a less than t less than b, agar if the interval is like that, then the function value is multiplied by ut minus a minus ut minus b. ओके, सो ऐसे जितना पीस है सभी पीस के लिए फंक्शन वैल्यू इनटू ये वाला इंटरवल का एंड पॉइंट के हिसाब से ये दैट टर्म शुड बी मल्टीप्लाइड. तो अकॉर्डिंग टू दैट फर्स्ट पार्ट है 2. ओके, सो 2 मल्टीप्लाइड ut minus 0, so ut minus ut minus 1, राइट. प्लस अब जितना पीस होगा इतना पीसेस के लिए सेम ट्रिक, प्लस प्लस करके जाना है. सो 1 by 2 into t square. टेल मी द सेकेंड पार्ट, बोलो. u t minus 1 minus u t minus pi by 2, दोनों एंड ये 1 है, ये पाई बाई 2. एंड थर्ड पार्ट क्या हो जाएगा, cos t इंटू, क्योंकि ये एक ही पार्ट है तो u t minus pi by 2. ओके, u t minus pi by 2. ये भी जस्ट t ग्रेटर देन pi by 2 है ना, ये a to b ऐसे फॉर्म में नहीं है, t ग्रेटर देन pi by 2, इन दैट केस cos t into ut minus pi by 2. Do you get it?
Yes, sir.
So we can represent that function ft, that piecewise function, as a single function in terms of Heaviside function. मतलब इसमें 3 पीस था वो, बट वो 3 पीस को Heaviside फंक्शन यूज करके मैं एक ही फंक्शन में लिख दिया. Fine. That is the advantage of this unit step function. Now you can ask me यहाँ पे 1 लिखा है and मैंने ut लिखा है. Actually for t ये 0 से स्टार्ट हो रहा है ना, t ग्रेटर देन 0, तो 0 से स्टार्ट हो रहा है, ut का वैल्यू क्या होता है? For t greater than 0, ut value of ut is what? 1. ये 0 है, ये ut का ग्राफ है. So for t greater than 0 that value is 1. तो इसीलिए ut की जगह पे 1 भी लिख सकते हो. Do you get it? Why they have written 1?
Yes, sir.
अगर ये 1 पे satisfied नहीं हो, then you can means replace it by ut. No issue. Now I am asking you, you can tell me if ft is equal to t whenever it is 0 to 1 and say e to the power t whenever it is 1 t greater than 1. Can you express it in terms of Heaviside function? And if you can, then tell me. Tell me. It is a piecewise function, so we can express it in terms of Heaviside function. And how? T into ut minus 0 minus ut minus 1. You can write ut as 1 also. Okay? Plus e to the power t into what I will write?
ut minus 1.
Ut minus 1. This. So that is the way to represent a piecewise function into a single function in terms of Heaviside function. Now, after representing the piecewise function into a single function, okay, you can take the Laplace transform. मतलब ये function को Laplace transform मतलब ये वाला function का Laplace transform. Okay, so Laplace transform of this plus Laplace transform of this plus Laplace transform of this. Now you can apply the t shifting theorem, मतलब second shifting. Okay, here you can use the second shifting theorem to find the Laplace transform of this function. Okay, I will explain this in the next class. How to apply t shifting theorem.
Yes.
This form is also needed. It is the modification of t shifting theorem. Okay, that is also needed. You can remember this. Okay, in the next class we will solve numeric problems. I will give all present.
Yes, sir.